Hi, everyone, and welcome to the weekly Science Hour. This is Emily Lakdawalla. I'm with the Planetary Society, and with me today is Casey Dreier, also of the Planetary Society, as of a couple of months ago.
Hello.
And I'm here with what's become a bi-weekly event, an update on what's going on with Curiosity on Mars. Now, ordinarily, Fraser Kane from Universe Today is here to help me out, but he couldn't be with us today, so I've asked Casey to come on and help us out. And the way that this usually works is that I give an update on what's going on with the Curiosity rover on Mars, and then I open it up to you guys to ask questions about either Curiosity or anything else that's going on. One extra thing that we'll be doing today is that Casey will be bringing with you an update on what's going on with the Mars program out of NASA headquarters, because what's going on is actually not particularly good right now, and there are things you can do to hopefully make the future a little bit better. But before we get started, I would like to ask everybody watching this on Google Plus to please reshare it on your pages, +1 it. Give us a thumbs up on YouTube, give us a like on Facebook, anything you can to help promote and reshare this out to your friends and get as many eyeballs on it as possible. I was looking at our YouTube comments today and noticing just how many people said, you know, this video is great, but there aren't enough views on it. Why not? And it's because you guys are in charge of sharing it to everybody else. That's how social media works. So please do everything you can to promote the work that we're doing here. All right. So Curiosity is on Mars. It's been more than 2 months now. It's actually kind of amazing to consider how long it's been. The rover, as many of you probably know, encountered a small hiccup the other day. Curiosity had started its very first soil sampling activity. This is where it uses the scoop on the end of its robotic arm to grab a small soil sample. And before it can actually use any of these for science, it has to run through a cleaning process. It may sound weird to be cleaning the insides of this scientific instrument with Martian soil, but it's actually necessary because inside all of Curiosity's electronics, all of its instruments and tools, there is a fine, very thin, microscopically thin, but it's there, oily sheen of unavoidable stuff from Earth, is really for lack of any better word. And in order to prevent that incredibly tiny amount of material from spoofing the results that we get in the incredibly detailed, incredibly difficult to work scientific instruments that are inside this rover, they actually need to use the sand on Mars to scrub the insides of these soil sampling tools in order to get rid of that oily sheen, clean it out, make sure that there's nothing but Martian stuff going into the scientific instruments before they begin. So they had picked up their first soil sample from a wind drift, a little sand drift called Rock Nest, and everything was looking great until they noticed something shiny on the ground. And there's been a lot of jokes on Twitter about scientists getting distracted by shiny things. The shiny thing, they've investigated it for the last couple of days, and it looks like a harmless bit of some kind of plastic. They actually called it benign plastic, and now naturally there's actually a Twitter account called Benign Plastic that's tweeting about its activities on Mars, and its hopes that ChemCam isn't going to laser it. I don't think they are. Most likely, it could have come from the rover. I actually wonder if it might have been material that came from the descent stage, which after Curiosity landed was cut off its cables and rocketed away a couple hundred meters and then crashed and smashed to smithereens on the grounds as its high-pressure hydrazine tanks exploded. There was certainly a lot of plastic, a lot of Kapton tape on that thing. There was plastic wrapping the fuel tank. So I would actually be quite surprised if we didn't see some debris from that impact being blown around the Curiosity landing site. So this may not be the last time we see that kind of material. So they're ready to go ahead now with their first shaking of the soil sample inside the robotic arm in order to clean out the tools and get going for the first of 3 actually cleaning routines that they have to do, where they vibrate the end of the robotic arm for several hours, or at least various planes inside the sample handling system are vibrated individually for about 15 or 20 minutes to sandblast the interior of this sample handling mechanism before they grab a 4th sample, and finally they will use that 4th sample to deliver it to the analytical laboratory instruments on the inside of the rover. In the meantime, they are taking some spectacular photos, and so I'm going to share my screen. First of all, let me just show you what the soil looks like that Curiosity has picked up. This stuff is incredibly fine-grained. It's the grains are almost too small to be seen with the camera. They're probably under 150 microns in size. They're certainly under 150 microns in size. That's slightly thinner than the average human hair. So this is very, very fine material, and it's exactly the sort of material they were looking for to use for their first cleaning activity. Here is a picture of the shiny thing. So you can see here's the soil scoop, here's the material inside the scoop, and it's this tiny little thing on the ground, and it looks a little bit reflective. It's gray, not red like the Martian soil, and in all likelihood it's a harmless bit of plastic. You can actually see some of the kind of plastic material that wraps wires here and there on the rover. And like I said, I suspect it actually came from the descent stage, although there's no way of proving that, and it's complete speculation on my part. Here is the view from where Curiosity is sitting, and it doesn't look like much because I'm not zooming in, but now that I zoom in, you can see back here in the distance, these are the black sand dunes that ring the base of Mount Sharp, the mountain Euless Mons at the center of Gale Crater. And the kinds of things that Curiosity is there to look at are these finely laminated rocks, and look at these really skinny thin layers that have been undercut by erosion, eroding out into plates. It's almost impossible to make flat, finely laminated, repeating laminated layers like that without the action of liquid water, without having fine-grained material settling down in relatively still liquid water. So it's going to be fascinating when Curiosity approaches these and has a chance to actually look at them up close with the scientific instruments and possibly even drill into them later. Here is a panoramic view from its current location, taken on sols 59 and 60. It's a full 360-degree panorama. So you start here, the mountain is in the south. This is the view to the north, and all in between you see the distant rim of Gale Crater. You see the mountain. We can zoom in and see the rover and its tracks, the arm ready to do some work. This position, actually, you'll see the arm in this position relatively frequently. They call this the ready out position. It's sort of like an initial salute that they do with the arm before they place it onto a target in order to do its work. These NavCam images are very low resolution relative to what they can take with the color mast cams, but they're absolutely beautiful. And then here I thought this was quite fine. So this is a montage that was put together by a guy named Stuart Atkinson, who has his own blog, writes a wonderful blog about what's going on at Gale Crater and with Opportunity on the other side of Mars. And he's put here together sort of a historical look at NASA's dirt digging activities, beginning with the robotic surveyor missions to the moon. And there's Apollo astronauts doing the same. Viking, of course, did a lot of soil scooping. Spirit did a lot of accidental soil scooping with its stuck robotic wheel that revealed, in this case, some pretty amazing silica deposits on the surface of Mars. And then there is Phoenix, and its occasionally kind of frustrating scooping activities performed near Mars's North Pole. And finally, here's Curiosity's very, very first soil scoop. So that's really more or less what's going on with Curiosity at Mars right now. It's been a relatively uneventful couple of weeks because first they are mostly focused on driving to get to Glenelg, which is the spot where they're beginning these investigations. And then they started getting ready for their soil sampling and got distracted by the shiny. But hopefully in another week or two, they'll be done with all of their soil scooping activities here, and we'll be ready to proceed to drive down into Glenelg, which is this region inside Gale Crater where there are 3 different kinds of rock materials that are all found in the same location. One of which is a rather exciting rock that they identified from orbit that looks like it could be the sort of material that was deposited in the kind of watery environment that Curiosity was sent to Mars to investigate. So it's going to be pretty cool if Curiosity hits pay dirt so early in the mission, and I'm really looking forward to that part. So it's time now, I think, for me to start answering questions. If you would like to ask questions, the places to do that are either on the YouTube video that you might be watching or the Google Plus post that features the Hangout. You can also ask questions on my blog, or you can ask them on Twitter using the hashtag TPS Hangout, TPS standing for the Planetary Society. So I don't know, Casey, if you found any questions yet.
I think you've been answering questions for people as they've been coming on your good overview. I was going to add that it was a happily uneventful last couple of weeks because I think everyone's breath kind of caught in their throat once they saw a piece of something on the ground that they didn't know what it was. So happily, that was far more boring than it could have been.
Although it's been pointed out that this is not the first time that a landed Mars mission has seen bits and pieces of itself on the ground. I think with when Opportunity landed, there was this little bit of white fuzz that actually looked like the Playboy bunny logo is what it looked like. So it was called the dust bunny, and it was actually seen to move around the interior of Eagle Crater, the little crater that Opportunity landed in. It was probably a bit of airbag material. And then my favorite one, I can't remember now if this was Spirit, I'm pretty sure it was Opportunity. Opportunity approached its damaged heat shield. It actually drove up to the heat shield, and the heat shield had crashed and turned basically inside out. And when you went up next to the heat shield, there was this gigantic spring on the ground. It looked like something that Wile E. Coyote might have bought from the Acme company. And that was one of the 7 push-off springs that are used to push the heat shield away from the back shell. But it was pretty funny to see that thing on the surface of Mars. It looked cartoonish.
We have one question here, which is a general question you could probably address, which is, what is the Curiosity robot looking for?
Well, yeah. So Curiosity is the latest and greatest in a really long line of NASA and European missions that have been sent to Mars to kind of follow up on the same theme. Basically, initially it was just reconnaissance, but then as we began to realize that Mars was a place that may possibly have had environments similar to Earth in the past, the question began to become, was there liquid water on Mars? And the Spirit and Opportunity rovers went to Mars and answered that question quite definitively, that yes, there have been places where there has been liquid water on Mars in the past. But what we don't know about that water is if it was persistent enough in the kinds of environments that would be conducive to life actually existing on Mars. And so that's the question that Curiosity has been sent to answer. Now that we know that there was liquid water moving about on the Martian surface at some time in the past for some amount of time, we're now trying to figure out if those kinds of liquid water environments existed where the liquid water was around for a long time, if there was nice chemistry, if there was organic material present in that water, if the water persisted in a relatively stable environment for a while, and if organic material that must have existed at the time, because there's always organic material coming in from comets and asteroids, if that material could be preserved in the geologic record in Mars's rocks. And so those are the kinds of answers that Curiosity is seeking. So Curiosity has been sent to explore some rocks on Mars that we already know from orbit. Really, they required liquid water to form. We have minerals and chemical identifications of minerals that really the best way that you can propose that they formed was because they formed in the presence of liquid water. But we still don't know these answers about the environment that existed at the time. So Curiosity is going to go check out these rocks at Glen Elk first, and then when it's done at Glen Elk, it's going to drive toward the mountain at the middle of the crater. And at the base of that mountain, there are particular minerals called clay minerals. And clay, to most people, is stuff that you make pots out of. But clay, to a geologist, is a very specific kind of mineral. It's a mineral that has a platy kind of chemical structure to it. And you make these platy minerals by altering more common igneous rock minerals in the presence of water. So you start out with minerals that are called things like olivine and pyroxene and feldspar. And when you do chemistry on these things in the presence of water, those minerals get turned into clay minerals, which have wonderful names like smectite. Smectite being one of the more exciting ones that they could find. So that's what they'll be looking for. A lot of the pay dirt in Gale Crater is actually at the base of the mountain, not on the mountain itself. But once they've done their work at the base of the mountain, you can bet these are all geologists. They're ready to climb, and they'll be climbing the mountain later.
Great. We have another good one here, which is...
hey, Casey, if you can, mention who it is who asked the question.
Sure. Jonathan Langdale asks from YouTube, I heard that the drill bit may have been contaminated because it was pre-installed, perhaps. It may have been contaminated. Do we know where it was first used or how it was contaminated on the way to Mars?
Yeah, so there's actually two drill bit problems that people have discussed in the past. One is this contamination from opening when it shouldn't have been opened problem. The other one is a problem related to Teflon seals inside the drill. So I'm pretty sure you're asking about the first one. That one was kind of, it came up in the news recently. It was actually an old story. It had originally come up in October or November. And it's really actually kind of a bureaucratic conflict between JPL and NASA. There's not actually any problem for the mission. The problem is that NASA wanted the mission to be using a certain level of planetary protection requirements on anything that was going to be interacting with stuff on the surface of Mars. And JPL did not handle the drill bits in precisely that way. And so if they were actually going to a place on Mars where there was ice at the surface, like the Phoenix landing site, then they would have been in trouble because there would have been the opportunity to contaminate actual extant water on Mars with a couple of microbes that might have hitched a ride because of opening the drill bits at the wrong time under the wrong environmental conditions. But Gale Crater is a place where it actually gets above the freezing temperature of water, what we regard as the freezing temperature of water on Earth, every single day. Now on Mars, because the atmospheric pressure is so low, water never exists as a liquid under current conditions. Even if you had any ice near the surface, it would rapidly turn into water vapor. It wouldn't even turn into liquid. It would go away. So there is no ice anywhere inside Gale Crater that is within the reach of any of Curiosity's tools, really under any conceivable possible circumstances. So the contamination issue, it would have been a problem if they were going to the Phoenix landing site. It's not actually a problem for Curiosity, but NASA was angry that JPL didn't follow the instructions, and so that's what that conflict was about. The other one has to do with Teflon inside. There's some Teflon seals inside the drill, and testing after launch showed that some little tiny bits of Teflon could come off and get inside the sample handling mechanism and therefore into the science instruments. And they're still working on that one, but they figured out that they should be able to account for and correct for any of the Teflon material getting into the analytical instruments. So they're still doing some work on that, but signs point to there not being a problem with the science on the mission.
We have another question from Writing with Robots on YouTube. Is there any real science to be had from cleaning the scoops? And I had this question too, so this should be interesting.
So you mean from
Can they do science with from the scoop processing that they do right now to clean it? Can they get any science, or do they just discard the results?
Right. So they can't put that material inside their analytical instruments, but you can bet that the geologists are learning a lot about the physical properties of that stuff as they work with it inside the scoop. One of the first things that they did was to vibrate the scoop, which has, as you imagine, you can imagine yourself shaking, putting some dirt in a jar and shaking it back and forth. You know what had happened. All of the big pieces of gravel would tend to come to the top, and generally you'd be mixing the stuff around. And so it's a really good way to see all of the different grain sizes and grain types of the material that are inside that scoop. Now on previous missions, even if they had the shaking ability, they would have had to take a picture, shake it, take another picture. They might take 5 or 10 pictures, but that would be all they got. With Curiosity's mast cameras, they actually have video capability, so you can go to the JPL's website, and actually, Casey, you might be able to find this video and share a link to it inside the Google Plus, the Hangout post. And you can actually see video of the stuff being shaken, and you can see little bits of gravel rising to the surface and going back down. So as a geologist, you can look at that and learn a lot about the grain size distribution. And grain size distribution tells you about the circumstances that transported the material to the current location. So there's certainly science to be got just from the vibration studies, but they're not going to be putting this stuff into the analytical labs. Okay.
We have another question from Philip Metzkin. Is there a scoop timeline available anywhere? When will they expect full science to resume or to begin, really?
It's funny. That's a very similar question to one that was asked by a member of the media at the last Curiosity briefing, which happened last Thursday, and actually there's another one happening tomorrow at 11 a.m. Pacific time. And so the response was kind of funny. The guy said, well, we're keeping the timeline deliberately vague. Because the fact of the matter is, this is what they call an FTA. You have to have acronyms for everything. It's NASA. FTA stands for First Time Activity. And so they have an order of events, and there's sort of things have to happen in a certain order, and it can't generally happen faster than any certain number of days, but you know when you do something for the first time that something funny is always going to happen in the process. In this case, it didn't have anything whatever to do with the soil sampling process. It was just the shiny thing on the ground that derailed them. So it's definitely going to take longer than they initially thought. They initially said 2 to 3 weeks for the whole process. It's been about a week that they've been here already. I'm guessing it's going to be closer to the 3-week point. So another 2 weeks from now, by the time that they're done with the first delivery of soil samples to the analytical laboratory instruments.
And if nothing else falls off the rover in the meantime.
That's right.
We have another question from Juan Nicolas Diaz Rodriguez, which is, besides the water, what other elements are NASA looking for or can be detected by the Curiosity rover?
Well, Curiosity, like the previous Mars missions, is being sent on a really important mission, which is to ground truth the orbital data. So we have these orbiting spacecraft. There's actually 3 operating at Mars right now. There's Mars Reconnaissance Orbiter and Mars Odyssey, which are both NASA missions, and there's Mars Express, which is a European Space Agency mission. And those are doing global mapping of the whole planet using cameras as well as infrared spectrometers. And so we get these wonderful global data sets, but they are all remote sensing. You know, you're detecting things from a very far away, and so it's really important to have something go to the ground and make sure that the things that you think you can say based on what you see from orbit are actually correct. And even though the rovers can only go to a couple of tiny places on Mars and not see the rest of the planet, just being able to verify your orbital measurements by going to those spots on Mars and checking them out with these landed instruments, do detailed chemical analyses, are extremely important. And in the time that separated the landings of Spirit and Opportunity and the landing of Curiosity, there's been kind of a revolution in our understanding of Mars's geologic history, where it's now thought, generally, although it's not accepted by all scientists, as no theory is ever accepted by all scientists, but the idea is that Mars has had this directional chemical geologic history, where in the very distant past it was a lot more Earth-like, with a more dense atmosphere, perhaps a water cycle. It may not necessarily have been warm enough for persistent liquid water all the time, but there was an Earth-like water cycle with a neutral pH rather similar to what we see on Earth today. And then as the atmosphere was blown away by the solar wind, because Mars doesn't have a magnetic field, so it lost most of its primordial atmosphere, this kind of environment went away at the same time as Mars was having a huge outburst of volcanic activity that formed Olympus Mons and the 3 Tharsis Montes, which is an incredible amount of volcanism that happened all at once. Volcanism doesn't just bring lava and rock, it also brings a lot of gases out from the interior, and they can be kind of nasty gases, especially things like sulfur dioxide. That it actually is a greenhouse gas, but it also acidifies the atmosphere. And so you wound up with any water that existed on Mars being incredibly acid, and that's the kind of environment that existed when the rocks that formed at the Opportunity landing site formed. Those rocks are all gypsum and sulfates. They're evaporites that formed in incredibly acidic waters. And so then after that last burst of volcanic activity ended, we kind of tapered off into the cold, dry, oxidizing environment that we have today, where all of the rocks have turned to rust, and there's not a lot more geologic activity going on beyond what happens with impacts and wind and occasional excursions into slightly warmer environments with Mars's pole tipping back and forth. And so Opportunity was lucky enough to be investigating one of these 3 eras. Curiosity, we know, is going to be the first rover to investigate the much more ancient clay era. And so that's actually pretty exciting. The Curiosity is going to be able to check this stuff out. Before we continue with another question, Casey, I want to stop for station identification. Again, this is Emily Lakdawalla of the Planetary Society here with the weekly Science Hour in conjunction with CosmoQuest. And we're here giving you an update on Curiosity and also an update on the Mars program. I don't know, Casey, if you might want to jump in with that pretty soon.
Sure.
Because I'm sure people will have questions about that too. We do these Hangouts once a week. Usually I alternate with Pamela Gay, bringing you the latest in science and space exploration, with what's going on with science across the solar system, and in Pamela's case, the rest of the universe. I keep my focus much more narrow. If you have any questions about what's going on, you can post them on the YouTube video, on the Google Plus Hangout, or send them via Twitter using the hashtag TPS Hangout. And for those of you who are watching, we ask that you please +1 it, reshare it, like it, do whatever you can to get the word out to the rest of the world that these interesting Hangouts are going on. So Casey, I don't know if you want to give another question or go on to talk a little bit about the Mars program.
Let's do one more question, and then we'll talk about the Mars program, then we can just take any question after that, just because it's so interesting hearing about Curiosity. There was a good question earlier about whether those flat bedded rocks you showed a picture of earlier were the same kind of, were the bright toned rocks seen from orbit, if those were the same kinds of things. And I'm trying to look who asked that question, but that's the gist of it.
The answer is I think that they are. I'm still having a little bit of trouble orienting myself to the to Curiosity's images. It's been a little bit more challenging with Curiosity than it has with Spirit and Opportunity for a couple of reasons. One of those is that Curiosity's cameras, the color cameras anyway, are much higher resolution than Spirit and Opportunity's were. So what that means, and they also have a much narrower field of view. They get more pixels, but in an image that covers a smaller amount of space. So it's a lot harder to figure out where you are on Mars in any of the Mastcam pictures. The other thing that's making it hard is that the Curiosity mission, for reasons I still haven't quite managed to figure out, is not releasing the same amount of metadata, that is information about the images, things like where the camera was pointed, as they did for Spirit and Opportunity. And so for Spirit and Opportunity, I have tools that various amateur software developers put together to help visualize where all the pictures are on the landscape. There are these virtual reality tools. There's a program called Midnight Mars Browser that's absolutely wonderful, that automatically downloads all the Spirit and Opportunity images and puts them up in this VR 360-degree panorama that you just move your mouse and you can swing Mars around you. It's absolutely amazing. And we don't have that for Curiosity because they're not giving us the data that we need in order to be able to see it. And I've been asking about this, and I really haven't gotten a satisfactory answer as to why they're not doing it. So I'm still hassling them, but so far without success. So that was a very long answer. In short, I think that they are, but I'm not positive.
Okay, well, let's move on to the developments in the Mars program itself and the challenges faced therein, and then we'll just open it up for questions after the end of that. So just as some background, Curiosity is kind of the pinnacle of this decade-long concerted effort by NASA to explore Mars. It really started with Mars Global Surveyor, and then followed by Odyssey and MER, and then the MRO, and then finally Curiosity being the big mega rover that it is. And so I'm going to bum everyone out now and talk about the challenges to the Mars program faced because of the budget cuts that we're hitting. So right before Curiosity landed in 2012, the current presidential administration proposed a new budget for 2013, and in that budget was a very harsh cut for planetary science overall, which is the whole division of NASA that runs every mission to a planet in our solar system that's not Earth and not the Sun, even though the Sun's not a planet. Of this 20% cut, 40% of this cut goes to the Mars program. The Mars program is what has run Mars Odyssey, is what has run Global Surveyor and MRO, the MER rovers, and Curiosity. And so this 40% cut basically stalled the Mars program completely, and they basically have enough money to finish Curiosity, and that's about it. So I'm going to screen share kind of the issue that we're talking about. This is the Mars program budget with and it's a lot of lines, but the important line is the red one. That's the 13, that's the proposed budget, and you'll see the big dip. That's the bad thing. It'll pick up in a few years, but basically what this means is that we lose a decade of Mars exploration if it's maintained like that. The challenge that the scientific community has given to NASA, and that NASA wants to do, is to pursue what's called a Mars sample return mission. This is where they fire a robot to Mars. It scoops up some dirt and actually returns it back to Earth so they can do all the kinds of science that we can't do on the surface with a mission, even with Curiosity's tool sets. So it's a big mission, it's ambitious, and it's incredibly exciting, and it represents the next step of Mars exploration. And so with this in mind, with the budget cuts, NASA was told, okay, here's what you're going to deal with. You have very little money. Go figure out how you're going to do Mars sample return. So just a few weeks ago, the results of the study came out, and this is what the potential future for Mars looks like today. So I'm going to screen share here again, and I'm going to say this is what they basically came down with. They're going to send a series of missions to Mars, maybe starting in 2018, maybe starting in 2020, and it's going to be multiple missions. The first mission will be a rover, either like Curiosity or like Spirit or Opportunity. These rovers will go rove around and then grab some interesting piece of Martian soil. Then they sit there and wait, and then we send another mission a few years later that lands, and what's called a caching retrieval rover goes and grabs the samples, takes it to another rocket. That rocket shoots it up into Martian orbit, and then we send yet another mission to orbit Mars, dock with that sample in orbit, and then fire and come back to Earth and land on Earth. So it's a complex set of missions, but the problem with this is that we're looking about 2018 to 2028 as a timeline for this. So basically pushing it off into the next decade. The real interesting things, though, are the types of missions that they're going to do. And the really comes down to either a rover that looks like MER that can cache things, or a rover that looks like Curiosity but has these giant tail fin solar panels instead of a nuclear power source. Both of these basically have to depend on a new orbiter to go at the same time, and so we're looking at a time scale of, again, about 6 years with the current budget situation. So the real important thing to remember is that NASA's working with very, very little here. And they're trying to do something incredibly ambitious with a cut rate budget. And that's basically going to delay the next mission for a good 6 years. So the state of the Mars program, at the same time, these missions look really cool, right? They can be really amazing if they pull this off. But even with an increase in budget, it's unlikely these will happen anytime before 2018. Did I bum everyone out now?
I probably did.
Yeah.
If there's any questions about that, don't forget to ask them. I can feed them to Casey.
Yeah. Just to address what may be a common question, there's a mission launching in 2013 called Maven. That's the last set mission in the NASA Mars program. That's what's called a scout mission. That means it's a very low budget mission, very good science, but not the big kind of mission that Curiosity is, and that's going to orbit Mars looking for historical, kind of examining the atmosphere of Mars. The other Mars mission, which you may have heard about, is called InSight. It's going to be scheduled to land in 2016. That's actually not part of NASA's Mars program. This is a weird kind of bureaucratic issue in how NASA deals with these things, but it's a separate funding part of NASA called the Discovery mission. And even though it's going to Mars, it's not really considered part of this stepwise ultimate goal, singular Mars program focus. It's kind of a mission that just happens to be going to Mars, but it's kind of run out of a completely separate thing. So it's going to do good science, but it's not going to get us any closer to these big questions about Mars sample return that we're looking for.
I suppose if I were listening to you, Casey, my big question would be: is there anything that I can do about this?
Well, yes, there is actually. So the Planetary Society has been working very hard all of this year. Once the budget was first announced back in February, we're trying to rescue not just the Mars program, but overall the planetary science program, which I said earlier is getting cut by about $300 million or 20%. You may think to yourself, $300 million, that's a lot of money. But then you think, oh, as part of the federal government's budget of $3.3 trillion, it's approximately diddly squat, I think, is the percentage of the total budget. And so it's a very small number, but it has a very devastating effect to NASA's ability to continue exploring the planets. And so the Planetary Society has been getting its members and other people to write their congressmen. We've had people write the Office of Management and Budget, which helps control how NASA spends its money. And actually just launching today, and it's actually up there now if you go to planetary.org/SOS, we have this new campaign, which is We're Writing the President. And you may say to yourself, okay, the president's probably got a lot of things on his plate right now, which is true, but the people at the White House, the staffers and the science staffers, they're going to be looking for and reading these messages from people. So it's very important, actually. This is kind of the last bit of the puzzle that we've been pursuing all year. We've had people write legislators. We've had people write people in the bureaucracy and the administration. And now finally we're saying we're going to write the big guy in the White House, and he's the one who can say to the Office of Management and Budget, hey, give these guys their money back. Because, again, these cuts happened before Curiosity landed. And so that kind of success shouldn't be kind of punished with budget cuts. And it's just getting that message through to these people. So we have a new campaign today to write the president. We're trying to get lots of people. We're just gearing up on it. We're coordinating with other people at the American Geophysical or Geological Union?
Geophysical.
Thank you. And the Division of Planetary Sciences and other groups trying to get them to write Obama. And again, these messages count, and even if Obama doesn't win, he's still setting the budget outline for 2014 that they're going to start working with. And so it's important regardless of the election.
Casey, there's a question here for you from Space Colonizer who says, hasn't Mars gotten enough attention lately? Why can't we start spending our limited budget on a mission to Titan? Or Europa.
Yes, or Europa. Actually, Europa is the other. So,
Titan, I don't want to hijack his question. He wants Titan. I'll throw Titan out there.
Yeah, well, Titan, I was also heartbroken by the fact that the Titan boat was not chosen as the Discovery mission. That's the one that went to Mars. Part of the issue is the way NASA decides what to invest their limited budget in is really driven by the scientific community. And so back last year, there was this thing called the Decadeold Survey that was released. The Decadeold Survey happens every decade, and it's a huge, complicated, long-term survey of all of the scientists in the planetary science community. And that report basically states a summation of the most important scientific questions from the community itself. Last time it was run by Steve Squires, who some of you may recognize as the principal investigator of the Spirit and Opportunity rovers. But again, he's not directing the contents. It's a survey of the larger community of planetary scientists. And the larger community of planetary scientists said that the most important scientific question is to be solved by returning a sample from Mars. And so that's the most important thing for the community. The next most important thing after that was a mission to Europa, which is what Emily was talking about. I'm not sure what was third. Titan's certainly up there.
No, the third most important mission, this was a shocker, I think, to a lot of people, was to send an orbiter to Uranus, which of course got me very excited. Uranus is my favorite planet in the solar system, I think.
I've always had a soft spot for those big blue ones.
Yeah, exactly. So, and that mission, as outlined in the Decadeold Survey, would have been cheaper than the other two, although there's actually a long history as to why the Europa mission looks as expensive as it does. It's all part of the sausage-making process that goes on when you are running scientific things from Washington, D.C.
Yeah, and again, there is a lot of people in the scientific community who are very frustrated, especially outer planet scientists, that Mars gets so much attention. Mars also, again, just has the benefits of relatively it's close. We've been there a lot, so we have a better idea of how to land there, how it works, and you send something to Titan, and it'll take a decade to get there. And so that's again part of the reason why Mars tends to be more attractive.
We do have a couple of other questions coming in about the Curiosity mission as well, so I'll jump back to a couple of those. The first one is from Andreas Vasinakis, and which is, how high on Aeolus Mons is Curiosity aiming to travel? That's actually a very good question. You see this mountain and you want to climb it. But as a matter of fact, most of the mountain that you see is made of this material that's called Yardang forming material. It looks like stuff that it's a sedimentary material, but it was probably windblown into place. It was not. It doesn't represent that watery environment that Curiosity is sent to investigate. So if you look at the pretty pictures that show the mountain in the distance, and you see these cool buttes and hoodoos and stuff, the buttes and all of those things, there's some nice layered rocks. Some of those are the more watery environment type stuff that Curiosity wants to see. But above that, there's this funky, eroding, kind of vertically ridgy sort of material. And that stuff is probably of much less interest to the rover. And so there may not be a there may not be a payoff to going much higher on the mountain than really just a couple thousand meters up. But a couple thousand meters up is really very high. And so as Curiosity begins to start climbing this, the views are going to be absolutely incredible. There are plans to go up. You know, Curiosity, like any other intelligent thing, climbing a mountain is not going to go straight up a peak. It will go up valleys between peaks in order to get access to the stuff that geology has helpfully carved nice, vertical slices through the landscape in order to get Curiosity a good look at those layered rocks. So don't imagine Curiosity peaking the mountain. I can promise you that that is not going to happen, but we will get high enough on its flanks to get some good views, I think.
Can I jump in? I saw an interesting question that is a little bit of both here, which is someone asking, why don't they send a rover with legs to Mars? And I actually just wanted to bring up really quickly this interesting side note that was mentioned. It wasn't actually really discussed in this presentation from the Mars Program Planning Group, which is, see down here, one of the potential missions to Mars that they looked at was an athlete mission. An athlete being that big-legged, though I think it has wheels at the bottom of it, but it still has a kind of a legs to it. And you'll notice also that the estimated cost was TBD because they've never done anything like that before. And again, to answer the real question, it's probably because the technology is untested and probably expensive to do. And risk at this point is they want to keep it as low as possible.
Yeah, it's funny, JPL and actually space exploration in general is this really funny mix of conservatism and great brand new out-of-the-box thinking, where you have to do something revolutionary in order to explore a new environment in space. But in order to have any hope of success for the mission, you want to go to space with tried and true technologies. So that's why you have funny combinations like a rover descending to Mars on cables with a jetpack and all kinds of an amazing landing mechanism, along with navigation cameras that have only 1 megapixel CCDs. It's because they can't push the edge of the envelope on absolutely everything that they do. They have to do it in small steps where there is technological risk, there's budget risk in some parts of the mission, but it's a lot safer in other parts of the mission. Casey, are you there?
Yeah, I'm here.
Okay,
can you hear
sorry.
me?
Yeah, sorry, your video stilled for a second.
Okay. There's another question here. Someone mentioning, Jason Hunter mentioning Kickstarter. I'd be willing to give money. I'm sure many people would also. That's kind of an interesting issue. I think there's the Uwingu group, is a group of planetary scientists actually who did a Kickstarter or Indiegogo, I think, campaign to raise about $80,000 to do something with planetary science. And it's an interesting test. The problem with Kickstarter is even if you raise $10 million, you're still about $2,490,000,000 short of a mission like Curiosity. And at the moment, there's been just nothing on the scale of money raised necessary to really do an intense mission.
Although, some of these missions, the missions at the couple $100 million level, it's a lot of money. I don't think you'll see anybody raising that much on Kickstarter anytime soon. But it's getting closer and closer to discretionary spending for the hyper-rich people that we have around right now. So One of these days I'm hoping that somebody with really deep pockets is just going to say, we want to go to Mars. And the fact is that if it's somebody who is not paying NASA to do it, the mission's going to be cheaper. It'll be riskier, but it'll be cheaper. And you have organizations like, India is actually talking about sending their first orbiter to Mars. It's under construction right now, and their mission will cost about $75 million. It may not be successful, but if they put together 5 of those and one of them succeeded, it would still be cheaper than a NASA mission. So it would be a slightly different way of approaching things.
Yeah. Phobos Sprint was 125 million, I believe, along that lines. And then you have things like the B612 Foundation, which is trying to raise $400 million to launch a space telescope.
Mm-hmm. Yeah, so I think it's beginning to get closer to democratization of space. I think one of the things that the Planetary Society has always been really interested in is the notion of sending really tiny rovers to the surface of the moon, many of them which would be useful scientifically. But another exciting thing about sending tiny rovers to the surface of the moon is that you could actually joystick them from Earth. And when I say you, I mean you. I mean the people who are watching this show would be able to compete or sign up for or something for a chance to actually operate a rover driving across the surface of the moon, which I think would be absolutely incredible. We worked on this before through a project called Micro Rovers, and I hope that one day we'll actually see it come to fruition. Yeah.
And I guess Bill Nye would be upset if we didn't mention that the Planetary Society is trying to make its own space mission in terms of light sail or solar sail, though it's not anything on the complexity of a rover. It's still a way for a Kickstarter-like campaign to raise money to send something into space that's entirely publicly funded, in a sense.
I see an interesting question from DMG 0003, who says he's wondered about gliders and balloon ideas for studying the atmosphere. Has that ever been brought up? It's funny you should ask that, because it's been brought up before by the Planetary Society. We actually ran a number of experiments with Mars balloons. We actually did some tests with these in the California desert. Obviously, we haven't sent one to Mars yet. But yeah, there certainly is promise for balloons on Mars. There's probably a lot more promise for balloons on Venus and on Titan. I know that JPL is working on a Venus balloon mission, has proposed it several times, but so far has not been picked up by NASA as a future mission. The same people who brought you the Titan Mari Explorer, the time mission that wasn't selected under the Discovery program, have also proposed a Titan Montgolfier, which is a balloon mission to Titan. Titan's atmosphere has the density. It's actually slightly denser than Earth's atmosphere at the surface, but the gravity is much lower. So Titan, if you really like flying, Titan is the place to go. Balloons would be great. If you had a human astronaut on Titan with a pair of Leonardo da Vinci wings, he or she could just fly around under human power, under Titan gravity, with the Titan atmospheric pressure. So there certainly is promise for using airplanes to explore and balloons to explore other planets. An airplane has actually been proposed for a Mars mission to the Discovery program, I think. Or maybe it was a Mars Scout proposal. Mars Scout is the mission line that brings you Maven. It is a possibility. I don't know when we'll see one, but it would be very exciting if we did.
That's one of those pushing the risk envelope a little high that makes it a difficult choice compared to some other missions.
Well, that's why you do it under the Discovery program, and
yep.
one of the things that Discovery is for, is to spend a little bit less money on a less expensive mission, and it's okay to have slightly higher technological risk, which makes it, I think, rather disappointing to a lot of people that InSight was chosen over Time and the Comet Hopper, because not that they don't like the InSight mission. InSight's going to be really awesome, but it was the safe choice of the 3. And I think there are people who are not happy that the opportunity to use the cheaper Discovery line to try out one of these new technologies, mainly the Stirling radioisotope thermoelectric generator, or landing on a comet, or floating in a freaking boat on the surface of a moon of an outer planet, that these opportunities weren't taken in the Discovery mission.
There is a question that you might have a good answer to, which is, what about Enceladus? Do you know of any missions that were proposed to Enceladus because it's venting its ocean into space? That's from Riding with Robots.
Yeah, I certainly have heard of ideas for missions to Enceladus. It's true that of all of the icy things in the outer solar system that are likely to have liquid oceans under their surface, Enceladus is, strangely enough, the easiest one to sample, because it's actually spitting its ocean into space right around Saturn, and you could do a Stardust-like mission that would just fly through the plume. You wouldn't have to land, you wouldn't have to have any complicated sample handling mechanisms. You just have aerogel, you fly through it maybe more than once, and then get it back to Earth. Of course, doing that at Saturn's distance from the Sun is a challenge, and I don't think that any such mission has actually been brought very far in any of the proposal mechanisms yet, but it's certainly been suggested. I think that my personal opinion, and I don't know how many other scientists share this, but my personal opinion is that Cassini is an absolutely fantastic mission, and it's not done yet, and that once Cassini is done with its mission, we are definitely going to want to follow up with missions to Titan and or Enceladus. That the time is not there yet, and it would be lovely if NASA was still doing its gigantic flagship missions at a cadence of one every 10 or 12 years, which is what they used to do. But now we don't have another flagship mission at all in the works, which means it's going to be at least 2 decades before any mission gets out to the outer solar system again, at least a big orbiter type flagship mission. And so that's gotten the outer planets community very upset and depressed, and maybe all kind of in a circle shooting at each other, because they know that for most of them, there's probably only going to be at most one more flagship mission sent to the outer planets in their professional lifetimes. And
hey, Emily, we have
yeah.
Bill Nye saying hello to everybody watching our Hangout at the moment. Bill?
Hi, everybody. We're hanging out.
This is one of the joys of working at the Planetary Society, everybody. So Bill just got back from representing us at the International Astronautical Conference in Naples, Italy.
Congress. The Congress.
Excuse me.
It's all it has program with 2 M's and an E.
Yes. So Bill has to do all the hard stuff while we sit around and
it was tough
here in Pasadena.
Hey, Bill,
it was good. We schmoozed people. We're trying to get our light sail to fly, and I saw the heads of agency meeting, and pretty much NASA, ESA, Canadian Space Agency. Boy, our budgets are really tight. Boy, our budget's really tight. Chinese Space Agency. Oh, it's fine. Yeah, we got plenty of money. We're on track. Yeah. Okay. All right, you guys. Let's hang out. Hi, everybody. I got to go right now. I'm not kidding. I'm going to CNN right now to talk about the House of Representatives Science Committee.
Oh, yeah, that guy. Thanks, Bill. All right, that's your bonus bill for today, everybody. Is that a good point to end? We're at about an hour.
I think it probably is a good point to end. I was just trying to grab a screen cap, and I managed to grab one with Bill's eyes closed, so I'm going to have to go back into the YouTube video and grab one of those in order to use that as a screen grab for the Hangout. But yeah, I think this is probably a good point to end it. You're certainly welcome to ask more questions. We'll follow up with answers on Google Plus and on YouTube. And I hope that you tune in also tomorrow. There's going to be another Hangout, a CosmoQuest weekly science Hangout with all of your favorite space bloggers. I may or may not be able to attend, but the usual gang like Fraser, Kane, and various others will be there discussing what's going on in the rest of the universe. So that's tomorrow, Thursday, 10 a.m. Pacific Time, 1700 UTC. I'm Emily Lakdawalla with the Planetary Society. You can find me blogging every day at planetary.org/blog. The Planetary Society is the world's largest non-governmental space interest organization. We are an international organization. We are a membership organization. So if you like what we do, please go to planetary.org and find the link that says join, and join us and help us out advocating for future space exploration and the peaceful exploration of space by all countries of the world. And Casey, thank you very much for helping me out today.
Happy to be here.
And tune in again in 2 weeks. I'll be back with another Curiosity update. So thanks, everybody. Bye-bye. See you soon.